Hello folks. I don't really know whether it's me or not. Maybe I haven't been around this flat earth thing long enough. But it seems to me that the arguments that the flat earth people keep putting up are getting more and more stupid. More and more outrageous. So, let me give you an example. I had the opportunity to go to one of these flat earth debate shows that are put on by Nathan Oakley. And one of the most outrageous thing I heard from Nathan Oakley and his little group of parishioners was that light does not behave as a wave. Well, I thought, even though I have covered this numerous times, I haven't actually gone over the things that differentiate light in terms of a wave and in terms of a particle. Now, of course, Nathan Oakley nor any of the other idiots that were with him offered any idea about what light was. In fact, to them it's they don't know what it is, but they know it's not a wave. They've got no reason to suspect that it's not a wave. They don't know why they don't know that it's not a wave, but they just know it's not. That's pretty much the same kind of standard of argument that you get from flat earth people. Anyway, I thought I would just cover this briefly to show any potential flat earthers why light does behave as a wave. Okay, and how does that compare with light behaving as a particle? Alright, let's kick it into gear. Okay folks, well, let's have a look at the board and work out why it is that we think that light behaves as a wave and also as a particle. Alright, so this is often referred to as the particle wave duality. Alright, so let's first of all have a look at light as photons. Here is the electromagnetic spectrum. At that end of it, over here, you have very, very long wavelengths. Wavelength meaning peak to peak of the wave. Okay? And over here, we have microwave. So as the wavelength gets shorter, okay, here we have infrared, visible light, UV, X-rays, gamma rays. As we come to this side here, wavelengths gets shorter and shorter. Okay, higher and higher energy as we get this side. Okay, well, as a matter of fact, both wave and the particle model will work for this to some extent. But as I'll show you later, the particle model breaks down in many of these areas. Well, first of all, let's think about what a photon is. So a photon is a packet of energy, if you like. Okay, in fact, we can quantify it. We can describe the amount of energy in a particular photon. So if you think about a photon as the smallest particle of light that's possible. Okay? Alright, so energy is Planck's constant times the frequency. And the frequency pretty much is, if you like, is telling us what the color is. Alright, or the nature of the photon. Okay, alright, so let's have a look here at these columns. First of all, we'll look at the observation. And then in this column, we're going to look at the particle model, whether or not it fits the observation. And then we have a look at the wave model and see if that fits the observation. Okay? Alright, so rectilinear propagation of the wave. Well, if you have a look at over here, that works in the particle model. So that works the particle model, and it also works for the wave model. We can measure the speed of light. Okay, it has been measured many times and in different ways. And turns out it's almost 3.0 by 10 to the 8 meters per second. Alright, another thing that light does is reflect. So let's have a look at reflection. Is reflection explained by the particle model? Most certainly does. You'd expect it to. Is it explained by the wave model? Yes, just as well. And there it is. We have an incident ray and a reflected ray being equal. You'd expect that kind of thing to happen for both models. We have partial reflection. For instance, we've got and total internal reflection. Now, when that comes to the particle model, some of that works quite well, and in other ways it's weak. Okay, as it traverses from one medium to another, the particle model doesn't work too well. However, the wave model works perfectly. And for total internal reflection, for instance, an example would be fiber optic cable. Dispersion, you'd expect it to work with the particle model, and it does, just like ordinary reflection does. So dispersion works. And of course, it also works with the wave model. And then we have refraction. Refraction does not work with the particle model. So this is where the particle model fails, with diffraction. Whereas with the wave model, it works perfectly. So over here in diffraction, we have light being broken up into its constituent colours. Okay, that can't happen with the particle model, but is perfectly explained by the wave model. Refraction, again, very badly explained in the particle model, and extremely well explained in the wave model. And then finally, polarization. Polarization is a clear evidence for the wave model. And no, it does not work in the particle model. Polarization relies on waves being either in one direction or the other. And it's impossible for the polarized material, to stop a particle. But it can easily stop the waves. So, polarization, fully explained by the wave model, and not at all explained by the particle model. So, in a nutshell, of course, light behaves like a wave. And one of the most important experiments was Young's double slit experiment, which showed that light shining through two slits would cause a diffraction pattern against a screen. And this is because of the wave function of light, the way that light behaves as a wave. In particular, the dark fringes caused by destructive interference of the waves, and the very bright fringes are caused by constructive interference of the waves. This is just absolutely cannot be explained by the particle model. Well, that's enough for this video. And as I said, it seems to me that this flat earth nonsense is getting worse and worse, as time goes on. Not that there's more flat earthers, but what they say is more and more stupid. Okay? So there's plenty of opportunity to have some fun debunking what they say. Okay? And I've heard quite a lot of stupid around lately, so there's a lot of fun to be had going over what they say. Now, I am approaching 1,000 subscribers, so if and when that does happen, I'll probably have a bit of a celebration. I might try my hand at live streaming. I'm not sure. Otherwise, I will probably just be hosted by someone else. In any case, we're sure to have a bit of fun. I think I might do a few roasts on that day. Okay, and that might even be from debunking channels. Maybe, maybe I'll make some enemies. We'll see. Okay. Alright, so if you like my videos then and you want to watch that in particular, press the subscribe button and press the bell, and you'll know when I'm putting that on. And if you like the video, press the like, and if you didn't like the video, you're probably a flat earther, press the dislike. Okay? But remember this, light does act like a wave. Okay, flatties? See you next time.